Welcome to this tutorial, and in this tutorial we're gonna solve these questions here, and these are questions that have to do with solving equations that are involving the modulus. Solving equations involving the modulus, and as you can see there's a modulus in these questions, and we want to know how can we solve this. So we're gonna get to do two approaches here. One approach which we're gonna say is the graphical method in which we're going to solve this, and the other method is us using the definition of what a modulus is in order to solve this. So the other one is going to be on the definition of the modulus. So, and if you remember, if you have x, the modulus of x, this can be redefined as square root, then this is what x squared, like this. So we use this definition in order to solve these equations. All right, and we're gonna just solve three questions here, and those are the questions that are checked in red. And so you have question A, and A says you have the modulus, so you have a modulus 2x minus 1, like this, and the modulus equal to what? X plus 1. How do you solve this? So solving this, we're gonna use the graphical method first of all. So we have to graph this, but then we have to redefine what the modulus, this part where there's the modulus, which is 2x minus 1 in terms of a piecewise function. And this is gonna be equal to, so write it as a piecewise function. When it's positive, that is 2x minus 1, this is gonna be positive, or it will take up a positive version like this if what? If x is what? So what you do is you equate whatever is inside there, x minus 1 equal to what? To 0. Then you solve for x. And you see that this is going to be x equal to what? X equal to half. So this is what you get. So this means this would be 2x minus 1 if x is what? X is greater than or equal to what? Equal to half. That's when we have this type here. Okay, then the other one is negative. So negative 2x minus 1, the function which you have, it's going to be negative like this if what? If x is less than what? Less than half. So this is how you redefine your modulus like that. So now, notice with me that what you have here, since we're going to use the graphical method, is you have your 2x minus 1. And what you're trying to do is you want to reach, what if you just had this 2x minus 1? How would you graph this? So this would be a line. So if you have your number line like that, I mean your xy plane, you have the x and y there, then you see, as we found that our intercept when y is 0, x was what? X is half. So you have it as half here. Then the other one gave you what? The other one gave you, so you have x minus this. Let's say this is what y is. So if x is 0, you get y to be -1, and -1 somewhere there. Of course, you'd have a graph that would be passing through like that. Okay, that did not come out that accurate. Let me try to do it again. So let me use this 2. So you have it pass like that at -1. So this is what you would get. Then there you'd be a -1. That's if I just to graph this linear function here. But now, because it's put in a modulus, what does that tell you? That tells you that we cannot have any negative values. So what is happening is that it is being translated up to the positive. So here, where it is, you see that it will be translated like that here, going like that, meaning right, pass through -1, here to pass through +1, not -1, to pass through +1. So it's going to be translated like this because of what? Because of the modulus there. And that's how you'd graph it. So let's graph this entire thing here. Let's graph the entire question here given. So we have, draw x or y plane like this. So show my x or y plane. Then I have that this graph passes or cuts where. So you have this positive side of it. So we had, so the same way we had graphed it as just a line, but then reflecting the side which was in the negative region to the positive region. But now you already understand that because it's in the modulus, you always have positive values there. So you just go ahead and directly graph it that way. So meaning you have one side this way, and you have the other side going on. Now, how do we label this? So we can label this looking at this side, so this is the positive region. So this is where x is greater than or equal to what? To 12. So this is where I write my what? The equation. So this here just represents the equation. That there represents that equation. Say 2x minus 1 this side. And on the other side, it will be the one which is what? Which is negative there. So meaning I'll have, and I multiply this negative through that there, I just get negative 2x, and that is what? It's 1. This is on this side, that will be right there. So now, what is the other thing that we have to consider? Now, we consider the other side of it, which is the x plus 1. And you know that x plus 1 is just a linear what? Linear function or linear equation where I just say, let's say y is equal to x plus 1. So when x is 0, you have y will be equal to 1. So that's the y-intercept. When y is 0, you have x equal to what? Negative 1. So you know that where that will cross, and so meaning we'll have something like this. So you have your, let me draw my line. Okay, let me draw. Okay, so drawing my line, I'm going to have something like this here. So something pass like that. So where you're saying where this part where it has crossed in the x, that is what? Negative 1. And where there it's passed, that should be what? That should be 1 here. Y equal to what? Equal to 1. But then you can easily solve this. How can you easily solve this? You can easily solve this by just saying, now look at where this graph, where they are crossing. You look at where these lines are crossing. This one for this linear function, which we found to be this linear function, which is what? X plus. So x plus 1. This line, and the other side, that's where it crosses. So what you do is you just equate these lines here to find what point this is, the intersection point. So the intersection point here, all the way down up to the x-axis. So remember, this is the x-axis, this is the y-axis. That is gonna give me my value, or that's gonna give me the value of what? The value of x there. So I'm gonna just equate, so the negative 2x plus 1 here to be equal to what? X plus 1. And what would that be? So take this x the other side, bring the 1 to the other side. I have negative 3x, and there I have what? Is 0. Divide by negative 3, and I just get x is equal to what? 0. And you can see really from the graph that where this intersects here, coming all the way down, this is a point where x is what? X is 0. And so that's the value of what? Of this equation. And that's how you obtain this value of the equation using the graphical method. All right, so we can also do this using, of course, the definition of what? Of the modulus. So I'll use the definition now. We see if we're gonna get the same what? The same answer. Where we say we have a modulus of x, we can just redefine this as root of x squared. So where we have the modulus there, 2x minus 1, like that, equal to x plus 1, I can redefine this side as root like that. Then I say 2x minus 1 squared equal to what? X plus 1. Then I can square both sides to get rid of that square root like this. Then this square root goes, and I just remain with 2x minus 1. So I remain with 2x minus 1. Then I'll have the what? Squared there. And this is gonna be equal to x plus 1 what? Squared. Then I can what? I can expand this. So to my left, what do I get? I get 4x squared. Then you get minus, that will be minus 4x. Then you have a plus 1. And there you get x squared. Then you have a plus 2x, then plus 1. Then of course you can bring everything. I choose everything to bring it to the left side. So I'll have, I just have 3x squared like that. Then there give me negative 6x. Then I'll have, so 1 minus 1 gives me 0. And this here, this side will give me what? 0. And then I can finish this up, just factor out the 3 there. I have x squared minus, that would be 2x equal to 0. Of course, notice that you can divide both sides by the 3, such that you remain with x squared minus 2x, and this will be equal to 0. Then, what next can you do there? So you can factor out this, you can complete the square on this if you want. So that's gonna be complete the square, not if you want, but complete the square here. you get x minus 1 squared, then that will be minus 1 equal to 0. And that is just going to be x minus 1 squared equal to what? To 1. Then taking the root both sides, even there, what do you end up with? So you end up with x minus 1. You have the squared there, and that there is going to give you what? It's going to give you, oh, that square root, that square has to go. Okay. So yeah, that square goes, and you just remain with 1 this side, and of course taking, okay, so you just remain with 1 like that. Then the 1 goes the other side, and you just remain with what? 1 minus 1 like that, and this here will give you what? Give you 0. So this will be x equal to what? X equal to 0. That's gonna be what? Gonna be your answer for what? For this. And you could see the same answer which we obtained when what? When we had used the graphical method. So okay, so one can say for, we have 2x there. Okay, so yeah, that's how you would obtain that. So if you try putting your 0 there, you have 0 there, and 0 minus, so you have the negative 1, 0 there, to the modulus, of course, you have 1 the other side, then you just have 1 equal to 1. So you can see here, if you say this is plus minus, of course, we forgot about plus minus, and this will give you one value be 0, then the other value is going to be what? This other value will give you x equal to 2. So x equal to, because it will be 1 plus 1, right? Negative going that way. So the 1 plus 1 and 1 minus 1 minus 1, which gives you what? Which gives you 0. So 1 gives you 2, and the other one gives you what? 0. So if you place 2 here, you get 4 squared minus 1. So what I'm saying is this. Okay, so after we obtain our value like that, so we are saying this was x minus 1 equal to, so we said root of 1, which is going to be plus minus 1, and you just get x to be equal to what? 1 goes there plus minus 1. So when you add, you get 2, subtract, you get what? 0. And you can test that both of these will be values of x, because 2 there, 2, replacing 2 minus 1 modulus, this gives me what? This gives me 4 minus 1, like that, which gives me what? 3 modulus of 3, which is just going to be 3. And on the other side, I just have 2. So 2 plus 1 is going to be equal to what? To 3. And you get 3 equal to 3. So 2 is the value of this, and x is the value. So when you're using this method, really, you want to test the values that you get, if they are really valid for what you're going to do. Unlike when we're using the graphical method, where we just get the one which we saw in the sect there, and that would be the definite value of what, of whatever we're calculating. All right, so let's do D now. We move on to doing D, and you see that D has the modulus on both sides of it. So now we're gonna work this out. So even for this one, I'll use the graphical method first. So you have, so redefine your 4x plus 9 like this. So equate what's inside to 0. So you have 4x plus 9 equal to 0, and you have what? 4x equal to negative 9 divided by 4, divided by 4. You have x equal to negative 9 over what? Over 4. So when you redefine, you're going to have that this will be 4x plus 9 if what? If x is greater than or equal to negative what? 9 over 4. And it's going to be negative 4x plus 9 if x is less than negative 9 over what? Over 4. So that's what you get for this one. And you do the same for the other one, which is 2. So the other one is modulus of 2x minus 1, like this. So redefine that, equate what's that there inside there, equal to 0. And you just get, this is going to be 2x equal to 1 divided by 2 divided by 2. You get x equal to what? To half. So it's going to be the first one, that's going to be 2x minus 1 if x is greater than or equal to what? Half. Then on the other one, it's going to be negative 2x minus 1 if x is less than what? Less than half. So that's what you get. Now, having these two, we can graph these what? These two. So how do I graph these two? So I drew my xy plane there, like that. Okay, so I know I'm not dealing with a negative down here because it's in the modulus. So everything is going to be reflected what? Reflected up. So the first one, there negative what? A half over that. That's what you're getting. So it's a negative half. Negative 9, I mean 9 over what? Over 4, which is like negative 2 point something. So you get it there. Then the other side again is going to be reflected like that. So this is how it's going to be. So what is that point? So this point here where this thing is, it's negative 9 over what? Negative 9 over 4. So that's what you get. Of course, is in the x, and that's the y plane. Then now the next one is you're gonna do the same. This one here, you have positive. It's half. It's at half. So you know you have one. Okay. So you know I have one going this side like that, and you have another going there like that. So this is what you have. And of course you can label these. I'm going to label them. So look at this one here. So the negative side, the left side is always the one that has the negative. So this is negative what? Multiply the negative inside, you get negative 4x like that, then minus what? Minus 9. Then this other side, which is positive, that's the first one, which is 4x plus 9. Then you have this one as well on this side, the negative side, multiply there, you get negative 2x plus 1. Then this side gives you what? 2x minus 1. So now you look at which sides of these lines are what are intersecting to find that value. So this is intersecting here, so meaning our value has to be here. It has to give us a value this side. And so what do? I get this value here where this side of this modulus is intersecting, and for the other one, then I equate them. So I have that 4x plus 9, and I will equate to, so this will be equal to negative 2x plus 1, since those are the only sides intersecting. Then what do I do with this? I then can bring this together. So I'll say 4. So okay, so I'm going to say this, the negative goes the other side, this becomes 6x, the 9 goes that side, and that becomes that will be negative what? Negative 8. Then I can divide this by 6 and I just get the value of negative what? Negative 4 over what? Over 3. So x is equal to negative 4 over what? Over 3. So that's how you do it graphically. So I then can even keep this value and see if, oh, am I gonna get the same value, one of them being this value, or when I use the other method. So this is negative 4 over what? Over 3. Okay, let me use the other method. So what will that be? So I erase this here. Okay, so the other one means I'm gonna redefine. So I have this left side to be 4x plus 9, then have a square there, then this will be equal to root, 2x minus 1 squared. You can get rid of those squares, the square roots, by squaring both sides, and you just remain with 4x plus 9 squared equal to 2x minus 1 squared. And what does this give me here? So this is gonna give me, so I expand this, I have 4 by 6, 16, 4 by 4, 16x squared. Then what do I get on the other one? Multiply this, I'll have 36 plus 36 give me a 72. So I have a 72x, then 9 plus 9 times 9 gives me 81. Then the other one here is gonna be 4x squared, then that will be minus 4x, then you got a plus 1. And of course you can move everything. gonna move everything to the left side such that I have 16 minus 4x, 16 minus 4x squared. That's gonna give me 12x squared. Then on the other side, that becomes positive. Then I just get plus, this will be plus 76x. Then this will be minus 1 to the 81. That gives me 80. So I have this here. Then I can complete the square here such that I have x squared plus, that would be 19 over 3. Then you get x there. Then plus, what's that? That's going to be 20 over 3. 20 over 3. So 80 divided by 12. That's just simplifies 20 over 3. And of course, this equal to 0, this equal to 0, like that. Then what do I get? There is a different ink here. So I divide both sides by 12. The 12 course becomes 0, and I remain with x. So here I can complete the square. I put that there. Then I have plus 19 over what? Over 6. 19 over 6. Since it's half of this coefficient of x, then I get squared minus. So 19, I have to square that 19 over 19 over 6. I need to square that. So what do I get when I square 19 over 6? So I get this will be minus 361 divided by 36. Then you have a plus 20 over what? Over 3 equal to 0. Then so what's that gonna give me? So I can simplify that. So 20 over 3, then minus 361 over 36, and that gives me, so this simplifies to x plus 19 over 6 squared. This will be minus 2, 121 over 36, and this will be equal to 0. Okay, so from there, take it the other side such that I remain with x plus 19 over 6 squared. This is going to be 121 over 36. Reduce the square root on both sides. So I'll have x plus 19 over 6 here. X plus 19 over 6. Okay, x plus 19 over 6 there. Then this here will be 11 over what? Over 6. Of course, we say plus minus. Then I'll say x to be equal to 19 over 6. Then I say plus minus 11 over what? Over 6. Okay, so what values do I get when I do that? So values I get, so I have x. So I'm gonna add in the first one. So I have 19 plus 11, then divided by what? By 6. 19 by 11 divided by 6, I get 5. Then when I subtract, that will be 19 minus 11. Let's do that right. So here we have been, oh, this has to be minus here. Has to be minus. So when you add the 2, so let's go back. So you have negative, because when you take it the other side, this becomes negative. So that will be negative 19 plus 11, and that gives you what? Negative. So negative 19 plus 11 gives you negative 8. So you have the negative 8 over what? Over 6, and this simplifies to negative 4 over what? Over 3, which is that first value there, which we found. That confirms. Then when we subtract, so that would be negative 19. Negative 19 minus 11, that gives you negative 30. So that will be negative 30 divided by 6, and this will be x equal to negative 5. So I can check really. Okay, so I'm not going to check this first one, negative 4 over 3, because it's the first one which we found there. But I'll check this negative 5 if it's really a value of this. So this will be modulus, where there's x, I put negative 5, then plus 9, and equal to 2, negative 5, minus 1. This gives me here to be negative 20 plus 9 modulus equal to This there is going to be negative 10 minus 11 minus 1. This here, what does it give me? It gives me negative 11. So you get modulus there of negative what? Negative 11. Modulus of negative 11. So negative 11 there on the left. And on the other side again, it will give you negative 11. And this just gives 11 equal to 1 to 11. So this shows you that negative 5 is a value as well. So you can use either of the methods. You still get those answers there. Right, so the next one, we will just use the graphical method, and that will be all for this video. So in a case where you have quadratic functions inside there, it's really good to use the graphical method, because when you start redefining, it becomes complicated because the polynomial degree increases maybe 4 to 6 to 8, and that's going to be a problem for you. So you rather just use the graphical method, because you know, if I'm going to redefine this x squared minus 4x there, this is just going to be what? So I'll get the positive version, that's x squared minus 4x, if what? If x is what? So if I say x squared minus 4x equal to 0, and what is this going to give me? I can complete here, that would be x minus 2, then minus 4 equal to 0, and x minus 2, then you just have this is gonna give you positive 4 square here, square of course, square, introduce the square root, both sides, just end up with this equal to what? 2. Just get the positive part of it, where you just get x to be equal to, take it the other side, this gives you, so you have a plus minus here, of course, then you have x to be what? X to be there, when you add, it gives you 4, subtract, it gives you what? It gives you 0. So you have these two here. Add gives you that, subtract gives you that one. So I'm gonna take well, no matter how you're gonna do it, no matter how I'm gonna do it, it's gonna still work out the same way, because here what you're interested in, if you say this is your y, your function y equal to x squared minus 4x, so what you're interested in here is trying to graph this. You have to graph this part of it, you have to graph this function. And what do we need to graph this function? Of course, we need intercepts, like we found 0 and 4. And what else do you need? So what else you need is maybe a y-intercept. So that's when x is 0, y is gonna be what? When x is 0, y is gonna be 0. So meaning that's your what? Your y-intercept. And really, if you are to graph it, so not considering the modulus, just the way it is, first of all, you have it like this, and when you're to graph it, you're just going to have so your intercepts, you have x0, and it also crosses at what? At 5. It also crosses at what? At x equal to 4, I mean. So x equal to 4, what's your y? So here as well, when you observe here how we factored out, you even have your turning points here. So your turning points, look at here, it's negative. So this negative what? 2, negative 2, or here, let me take it here, negative 2 and that. So negative 2, you always have to multiply this by negative such that you have a positive. No, I mean multiply this always by negative to get the x coordinate of the turning point. So negative 2 by negative 1, that's going to give me what? Positive 2. And you get this one here, that's going to be your y. So this is my turning point, 2 comma negative 4. And if I follow that, let's say my 2 is here. So say my 2 is here and my negative 4 is there. So my turning point is what is here. But where is this graph facing, first of all? So it's going to face upwards, since a is greater than what? Than 0. So I know it's facing upwards, and you have it to say it's passing through 0, passing through x and y, since y and x are 0 as the intercept. You pass through there, and it will come to 10 there, and it will go up this way, pardon my sketch, like that, let's say, and this is the point, the other intercept, which is 4. So you get it like this. But now because we are dealing with a modulus, what does that mean for us? Because we're dealing with a modulus, it means everything that is in the negative region has to be reflected in the positive what? In the positive region. And I would draw that now to say that graph which we are finding here, like that, has to be reflected in the positive region. So you have, first of all, I'm gonna have, so I have that going up to there, like that. Okay, that going, let me draw it again, like that. Then you have the other part then where it goes, it's the side like that. And in between here, it means it's gonna be reflected now like what? Like this. It's gonna be reflected up like what? Like that. That's how it's gonna be what? It's gonna be reflected. And of course it's kind of the same, so meaning this will be at 4 this time, and that still will be at 2. So the turning point is at not -2, but it's at 2. So the turning point now here, it becomes a maximum instead of a what? A minimum, and that will be at 2 comma what? Comma 4 instead of 2 -4. So that's what you get. Then now from here, what else are you supposed to then do? So you look at this side on the what we're equating to. It's at y equal to what? To 12. So that means this is going to be continue to go like that. And I have my y equal to what? To 12. So if I draw splitting, I didn't split that well. Let me draw a line like that. So presuming that where it's passing, this is at what? At 12. Moreover, we understand that these lines to my left and right continue to go up to what? Up to infinity. So I'll have that to be 12, and they'll intersect. So meaning here and another one intersecting what there. So what you're gonna do is remember the negative part of the equation. So you have 2 points, meaning that you're gonna get here. And so you have, so we say this if what? If x is, so this will be at x is what? Is greater than or equal to 0. Since we found 0 to be one of them, then I'll use the other one as x squared minus 4x if x is less than what? Less than 0. So this is what I get. But then I can just say, okay, from here, this side, the negative side, I know it's this gonna be this one, and the positive side is this one, and I'm just gonna be equating those two to 12. So negative side, that's negative, so that's negative x squared plus 4x. This is gonna be equal to what? To 12. So that's for the negative side, this side. So let me see what value I will get there. So, and of course it's values because it's a quadratic equation. So plus 4x minus 12, and this will be equal to what? To 0. So if I want, I can use the quadratic equation formula here, and I know that is x equal to negative b, then I have plus minus root of b squared minus 4ac, then over what? 2a. So what am I gonna do? My b is this here, and that is negative, so that there is negative, oh, it's gonna be -4 plus minus, then you square it, so square -4 gets 16, then what's minus here? Not a positive but minus. In that formula here there's a minus sign here, so minus 4ac. So minus 4, what's my a? My a is -1, my c is negative what? -12. So this gives me a negative value, which is gonna just be, okay, is this, okay, I will erase this part since we already understand what this is. So what do I end up with? So divided by, of course, this is supposed to 2, this is 2a, and my a is negative, so I get -2 down there. So you just get, this would be -4 plus minus, inside you have what? 16, and that will give you -48 divided by -2. Then So what you get inside here gives you a negative value. So root of that will be negative what, 32. So because of that, that's gonna, the negative here fails it all, because this is gonna give you imaginary versus an imaginary number, and we are interested in the real number system here to find. So we disclude this one, and now we just end it here and conclude that we're going to get imaginary values. But let's use the other one now, which looks at the positive version of it, which is x squared, or on this, which was at the right side, x squared, then this will be equal to what, to 12, and this will be x squared minus 4x, then will be minus 12 equal to what, to 0. So I equate again, that will be x, then that gives me, so it's negatives, negative by negative multiply, and I get a positive, then I have plus minus, and I have a root there, square that negative 4, I get 16 minus 4. What's my a? My a is just 1, and my b is what? My b is oh, my c, I mean, is negative 12. Then down there 2a, that just give me 2, and I have 4 plus minus inside. This I just get 64, then divided by 2, and okay, since I know that's a perfect square, I can evaluate that, and that is going to give me plus minus plus minus what, 4, right? So that will be plus my not 4, 8. So I have 8 there, and 2. Then I can divide the 2 both sides. I get 2 plus minus 4, like that. So the values of x are going to be, so when we add here, so when we add, we get 6, and when we subtract, we get negative what, negative 2. So this accounts for one which was to the right and the other one which was to the left there, since we saw that they intersected with what, with the line 12, one in the left region, which is to the negative, and the other one to the right region, and this is how you get your values. So this is how we solve equations that involve the modulus. If you are new to this channel, remember to subscribe and like and share for more content, and I'll see you in the next video.